Okay, today we are going to solve this next greater element problem, which is basically asking us to return an array of length norms1 dot length such that each element in this array answer should be the next greater element is described below. Okay, the next greater element of some element x in an array is the first greater element that is to the right of this element x in the same array. Okay, so you are given two arrays that are distinct, zero indexed, and contains integers norms1 and norms2, and norms1 is a subset of norms2, meaning each items of norms1 are the are present in another array norms2. So for each item, that is okay, what it is for each zero lesser than or equals to I item that is smaller than norms1 dot length, find the index j such that norms1, okay, is equals to norms2, okay, and determine the next greater element of norms2 j in norms2. Okay, if there is no next greater element, then answer for this query is -1. We have to return array. So what it is saying here is norms1 is a subset of norms2, meaning each item, okay, each item of norms1 is present in array norms2, meaning we have to find out four in norms2, and we have to return the next greater element to 4 that is from norms2 array, meaning 4 we have to find out in norms2. 4 is here. Is the next greater element? No. If not, we have to return -1. We have to return -1. And now we go for 1. Is there? We have to find a 1 here. Okay, we have to find a 1 over here. Next, and then we have to return next greater element 3. That's it. 2. We have to find out 2. There is no any element after 2, so we have to return -1. -1 -1. Okay, same thing, and can be only lesser than 1000. Length can be lesser than 1000. All integers in both arrays are unique and should appear in norms2. Norms1 elements of norms1 should appear in norms2, in array norms2. So how can we solve this problem? Okay, one way, there are multiple ways to solve this problem. Okay, there are multiple ways to solve this problem, but how we can solve this is first let's take an array. Okay, what question is asking? Okay, what question is asking us here is, from the given array, okay, from the okay, from, sorry, okay, from this given array, suppose 1, right, 5, 0, 2, 3, 9, 6, 8. Suppose we are given this array. Now we have to find out the next greater element to each item of this array, and then return the array. and then return the array of next greater elements. Okay, so the answer should be like this, right? One, we check. Okay, one, first element is one. We check, we check, we compare one with the next greater element. Sorry, with the next element is 5 greater than 1. We find out the next greater element. So we return 5. Again, we go to 5. We go to next element 5 here, and then we check with the another element 0. Is 0 greater than 5? No. Is 0 greater than is 0? No. We go to we compare to next element 2. Is 2 greater than 5? No. We go to next element 3. No. 9? Yes. 9 is greater than 5. So we return 5 over here. Now we go to next element 0. Is, and then we compare with 2. Is 2 greater than 3? Yes. 2. We compare 2 with 3. 3 greater than 3. 9. Now we reach to 9. We check with 6. Is 6 greater? No. And then we check with 8. No. Now we have reached the end. There is no other element. So if there is no greater element, then we have to return -1. Now we reach to 6. 6 we compare with 8. 8 is greater than 6. We return. Now this is the last element. There is no other element, so we don't have next greater element. We return -1. This is what the question is asking. We have to return an array containing next greater element of each item of the given array. Okay, each item of the array. Now, but how what we did here is we pick one item from the right? We pick one item, one element, and we loop through whole array for one item to find out next greater element for each item, right? Each item, isn't it? Isn't it? For one, what we did, we took one element, we check, we find out, right? It was fast, it was obvious, it was fast. But for five, but for five, 0 is not. We loop here, we loop through whole array. First, second, third, and then we finally find out 9, which is greater than 5, and then we return. So meaning if 9 was at the end, we have to loop through whole array till the end, right? Till the end, till the end. So it was, we loop through whole array. So basically, in order to solve this problem, the time using this method, the time complexity to solve this problem is the big O of n item times the, yeah, isn't it? Because we are looping each item through whole array. For each item, we are finding next greater element, right? Finding next greater element, which is O of n square. And it is not the good approach. It is not the good approach. We Yes, it can solve the problem, but it is not efficient enough. We can make this solution better. How? It is using stacks, right? Using stacks. Okay, let's go to let's first take the same okay, let's first take the same example. Okay, sorry, let's first take this same example. Control C, copy, right, paste. Okay. Um, 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 um. Give me the. All right. So this was a given array. Given array. Mm. Okay. This was a given array to us. We tried to solve it using by looping through whole array, comparing each element with another element and finding out next greater element, which for which the time complexity was O of n square, and that is not efficient enough. That is not a good approach. In order to make the solution better, we can use stack. Okay, we can use stack for if I explain in a simple way. What if we start from the end, from the last item of an array? Why from the last item of an array? Let's make suppose from a last item of an array, because the last item, after last item there is no any element present. So what we can do is we can return -1 directly, right? We can return -1. There is no greater element after the last element of given array, isn't it? Now we compare. Now what we do is, now let's first make an array. Okay, sorry, stack. Okay, we are solving it using a stack. Suppose this is an stack. First, what we did, right? Stack. This is a last element. This is a last element. There is no any greater element. We return -1. There is no any. And then we push 8 over here. We push 8 over here. Now what we do is we start comparing from the second last element. If array of index is smaller than top, top of the stack, which is at the moment is this. Okay, top of the stack is if that element 6 is smaller than top 8, then oh my god, sorry, next greater element equals to top. Okay, next greater element equals to top. Okay, next greater element equals to top. We update 8 over here. We update 8 over here. And then we push 6 over here. We push 6 over here in the stack. Okay, push 6 over here. 6 over here. Now we reach 8. Now we reach 8. Sorry, 9. We reach to 9. We compare with this one. No, it's not. It's not. 6 is not greater. 6 is not greater than 9. We check with 8. 8 is not greater than 9. We reach the end. There is no greater element than 9, so we return -1. Okay, we return -1, -1 over here. Okay, -1 over here, and then -1 over here, -1 over here. So while what we did, sorry, minus one second, -1 over here. Okay, -1 over here. Okay, 1 second. While while we were comparing to the another element, what we also did was, suppose while we were comparing 9 with 6, right? While we are finding the next greater element by comparing 9 with 6, what we did is, as soon as we find out 6 is not greater than 9, we popped 6 out of the stack. Okay, we popped 6 out of the stack. We pop this out. Okay, we we pop this out. All right, we pop this out. Right, we pop this out. Now after that, we checked with 8. Is 8 greater than 9? No. We popped 9 out of the stack. Control Z. We popped 9 out of the stack. Sorry, 8 out of the stack. Okay, 8 out of the stack. And then there is no element left in the stack, meaning there's no element to compare with. There is no any top element in the stack. What we did, we returned -1, right? -1. So what we did here was array of, if array I was greater than top, we popped, keep popping top value, right, until finding next greater value. Okay, until finding next greater value, else return -1. Else return -1. Else return -1. So we return -1. And then what we did was, we pushed 9 over here. We pushed 9 back, 9 into the stack. We pushed 9 into the stack. Okay, 9 into the stack. Now we go to 3, another item 3. We compare with 9. 9 is greater than 3. We return 9. We compare 2 with 3. 3 is greater than 2. We return 3. In 0 and 2, we reached 0. We compare 0 with 2. We find out next greater element as 2. Right. Right. And then while we were comparing and finding out the next greater element, we were also doing what? We were also pushing the values into the stack. 3, 2, right? Now 0, 0, right? 0. Now we reached 5. This is 5, okay? This is 5. We reached 5. We reached in this index, and the value is 5. We compare with 0. No, it's not, right? It's not greater than 5. It's not greater than 5. It's not greater than 5. We find out 9 is greater than 5. So 9 is greater than 5. So what we did, we return 9 over here. So what I said earlier is, while we were comparing with the top element, if that array value, if the value was greater than the top, what we were doing, we were popping the value out. So we were comparing with 0. 5 is greater than 0, so we popped out 0. 5 is greater than 2, we popped out 2. 5 is greater than 3, we popped out 3. Finally 9 is greater than 5, we returned 9. We returned 9. And then we pushed 5 into the stack. 5 into the stack. 5 into the stack. Now Which is to 1, 1, 5 is greater than 1. Yes, 5. So what we did, 5, we return 5, right? We return 5 and then we pushed 1 over here. All right, this is the next final output array that contains next greater elements. This is the output, okay? This is the output, right? This is the output. All right, convert this. Let's convert this into code, okay? Let's convert this into code. I'll solve it in LeetCode platform over here. All right, we have understood the problem. We have uh, also knew the logic, how to solve it, right? How to solve it, and now we have to convert this logic into code. Okay, we have to convert this logic into code. Hmm. Let's start. Okay, we have been given two arrays that contains integers, integers that is less than 1,000 and that are unique, and the integers, the array 1 integers are present in array 2 as well. Okay, and we will solve it using stack method. Okay, so stack and map. Okay, first of all, let's initialize stack. All right, let's initialize stack, and let's also initialize a map. All right, let's initialize map. Let length of norms2 be n, norms2 dot length be n. Okay, be n. Let's push the last item norms2 norms2 last item n minus 1, and also map equals to minus 1. Okay, all right, what I've done here is I've initialized the stack. Okay, obviously we are solving it using the stack, as I already explained while while doing the logic, how to solve part, that we will be pushing the elements into a stack, and we'll also be popping out. Now map, we will be using a map basically to know basically to map, we will be using it to store the, or we will be using it to store the mapping of each element in norms2 to its next greater element. Okay, and obviously we will be looping through the length of norms2 array. Okay, for let I equals to n minus 2 from the last, I is greater than or equals to 0, and we will go down. Okay, we'll go down. Let top element be stack stack dot length minus 1. This will be the top element, okay, in the stack. So top element in the stack, if norms2 is smaller than top, then we will store the element in map. Okay, map, right, map norms to I equals to top, right, top, else 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 if it is lesser than top, we store it in a map, we update the value, right, we update the next greater element, right, next greater element. If not greater than top element, right, while there is stack, while there is length, right, if norms to I, if the item of norms to current element is greater than stack stack dot length, that is basically the top element, then we decided to pop the item stack dot pop, right, stack dot pop, else map, else update the next greater element, map norms to go I equals to stack dot length minus 1, and after that we break, right, we break. If stack, if there is no stack dot length is 0, if 0, then we update it to minus 1, map norms to go I equals to minus 1, we update it, and after that we also push that element, so push the element, right, norms to go I. Now we have to basically, what we have to do now is we have to iterate through norms1, and using the map we'll iterate through norms1, and using the map we'll find the next greater element inside an array, okay, and basically store that into an array and return that array. Okay, how we are going to do that is let a result equals to, let's initialize one array, we will look through the length of norms1 dot length I plus plus, then we will result dot push map norms1 go I, right, and then return result. Okay, norms is not defined. It should be norms2. Okay, I got the wrong answer. Why? It should be 3, right? Expected 3. But I got -1. I forgot to let initialize here. I think that is not the problem. Stack dot length. If stack dot length, if norms2, if that element is greater or equals to that, then pop, else. Okay, map norms2 I, if stack dot length map norms2 I. Looks good, looks good, looks good. What happened? Result dot push, result dot push map. Why did I make mistake? Okay. Okay, I have done stack dot push. Push is a function. I have to enclose them inside a bracket. So this will solve the problem. Okay. It's not array. All right. This is how we solve this problem in better approach. This in this solution we are using stack and map. So space complexity for this problem is big O of n. Okay, big O of n, and time complexity is also big O of n. Okay, big O of n. Big O of n. If I have to explain it, we are pushing. If I have to. Okay. If I have to explain it, we are basically using a stack, okay, here we are basically using an stack to basically keep track of elements for which we are finding the next greater element. Okay, we are keeping the track of elements, right? And map is basically we are using it to store the mapping of each element in nums2 to its next greater element. Okay, here we are basically pushing last element from the array, and we are making sure that last element does not have next greater element. Okay, and we are basically storing it to the map. Yeah, map. We are using it map. Now we are looping from the end in array 2 nums2 second array. We're finding the top. We are picking and we are getting the top element from the stack, and then we are comparing with each element. If top is greater than that element, then we are updating in the map, updating the value in the map with the greater element, right? With the greater element. Else we are popping out. Else we are if that is lesser, if the top element is lesser than the than the that current element I, then we are basically popping the element from stack until we find the greater element, or or we are updating minus one is a greater value, right? And then we are also pushing that current element into the stack, and we are repeating that until 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 we reach to the first index, or until we reach to the end of the array. Okay, until we loop through whole elements of an array, until we loop through whole array, right? And then finally we are storing the uh, output in a result. We are looping through nums1, and we are pushing the values, next greater elements, next greater elements into result.